So that's a clip of a Supra Mark IV passing by a camera really quickly. Uh, did you notice how the pitch drops as it passes the camera? So
No, just
Yo,
it's okay.
no,
just
no,
keep-
no, no. Well, we're gonna do an experiment of our own to see if that's true. So what I've got here is an app installed on another phone. It basically makes a single pitch or a single frequency. Very, very annoying to listen to, but very useful if we're referring to physics experiments. So the idea is that the Doppler effect is actually more pronounced when you have one pitch, but we can start recording now, right? So when I pull out a song right here, it's recording audio, right?
Yeah.
When I pull out a song and I kind of wave it across the microphone like this, you can't really hear the difference. But now, if we swap it to a constant pitch, here you go.
Think of the microphone as you and this phone as the car. Okay, so if I'm
Yeah.
going to place I want to turn on the pitch generator here, so you can hear some pitch. All right, so we're just gonna tell me when, Kev.
Okay, 3, 2, 1, go. So, it's as he gets closer to the microphone, the pitch is probably gonna be high, and as he passes the microphone, the pitch is probably gonna drop. So you're gonna hear a pitch difference. But let's do it one more time, just for safe measure. You know, more trials. You know what I'm saying? Okay, you can go ahead and wait, hold on. 3, 2, 1, go. Okay, we should be good there. The ad's playing, isn't it? Oh my god. That's what you get for downloading a free app.
Yeah, that is what you get.
Yeah, because we're done here.
Okay, let's go back to explaining it.
Okay, so let's take a look at the audio that we recorded during the experiment.
42.
The first time Adrian runs past the microphone happens at 0:42. So we're gonna play that right now.
So you can hear some pitch, alright? So we're just gonna tell me when, Kev.
Okay, 3, 2, 1, go. There. You should have heard right there when Adrian passes the microphone that the pitch suddenly drops. You're gonna notice it at 11:16 as well, which is right here, which was during our second trial. Wait, hold on. 3, 2, 1, go. Right there. So as Adrian approached the camera, the microphone, the frequency was relatively high. But once he passed the microphone, the frequency sort of dropped and returned to its original position.
Yeah, so why is it that we hear this cool sound effect, otherwise known as a pitch shift, when a car passes us at a high speed?
Well, it's not just the car. It's like
Any source that you're observing. Well, this is because of the frequency that we observe. It changes. So, what is frequency exactly? Now, frequency is usually associated with how often something occurs. In this case, it refers to how often a wave repeats within a second. Let's take, for example, this simple sound wave, a sine wave. This is what we have here.
a sound wave.
Yeah.
So, as you can see, this diagram represents a wave, and right here where the wave repeats, so it goes up and then down and then back to sort of the same position where it was here. So it's gonna repeat again, and frequency is basically just how many times this iteration repeats every second. The frequency of the sound wave we hear changes. So what? Well, the frequency of the wave actually determines the pitch of the sound. So
Here
a
we
high
go.
frequency wave produces a high note or high pitched sound, which I'm gonna play here using the pitch app that I downloaded. No, it's 8,000.
Okay, 8,000 is pretty freaking. Yeah.
Ouch! No, that actually hurts. Okay,
That's
let's
right.
stop. And now we're gonna dial it down to about, I think like 1,000 is
1,000 should suffice.
there. You can hear that it's lower pitch than the sound we had before.
Yeah.
So let's apply this to our Supra Mark IV. And this is a diagram that I drew. I don't know.
Well, you can see it. Yeah, you can see it.
You see it on the
No, you can't. You just have to go closer. There. Just focus.
As the car moves, let's say this is a person, right? As the car moves towards the person, the sound waves here in the front are condensed and closer together. This is because the source, which is the car, is also moving in the same direction as the waves. This causes the person here to hear the sound waves more frequently because they're more bunched out together. However, as the car moves away from the person, the sound waves are more spread out, as you can see back here. This is because the source is actually moving in the opposite direction of the waves. The waves moving in this direction, and the source is moving in that direction. As the car passes the person, the frequency of the wave actually changes, as you can see from here to here, and that's what actually causes the pitch of the sound of the Mark IV Supra to change as it passes by.
In conclusion, when someone observes a moving sound source, in this case the car, there will be a change in the frequency of the noise observed. However, the sound produced by the car itself does not change. Because the car is moving, it changes how we observe the wave, which is what creates the Doppler effect and causes the pitch shift.
There you go. Well, if you have any questions, you can always contact us through the comments or whatever, and then we'll answer your questions. I guess it's a good way for us to learn as well.
Thank you for watching. Hope you guys learned something.